In this video, we'll be exploring the concept of factorization. If you are new to this channel, please hit that subscribe button and the notification bell to be notified whenever we post new videos. So I want to explore the whole concept of factorization. Now, this is the process of finding the factors. Alright, and what that simply means, finding what to multiply together to get an expression. So let's look at a basic example. Let's say we had the number 15 here. Alright, so we have 15. Now, we can find the factors of 15 by simply finding what we can multiply to obtain this number right here. Alright. So we know that we can multiply, I believe, 3 times 5. That gives us 15. We can also multiply 1 times 15, and that also gives us 15, all right? So these are all the factors of 15, all right? By doing that, we would have obtained all the possible numbers that can go into this 15 right here without leaving a remainder. All right, so that's what factorization is all about in the basic sense. All right, so that's a number. Let's say we had something, and I'm going to call this example 1. So we're going to look at several examples for the sake of this video. All right, so let's say we had example 2. What if we had 4x? Again, the factors of 4x would be what we can multiply to obtain this 4x right here. So factors of 4x would be 4 times x. All right, so this would be the factor or the factors of 4x. All right, now what if we had, let's say, example 3. What if we had 3x plus 15? What if we had something like this? Now we can actually obtain the factors of this expression right here by first finding the factors of each term. All right, so what are the factors of 3x? The factors of 3x would have been 3 times x. All right, how about 15? Factors of 15, we can multiply 3 times 5. That gives us 15. We can also multiply 1 times 15, and that also gives us 15. Now, what we want to identify, so this is what I did to obtain the factors for each term. All right, just want to highlight that this was the original question. Now, what we want to identify is the highest common factor for both 3x and 15. All right, so which of the factors is common between 3x and 15? So down here we have the factors for the 15 just to separate that. So if we look at this thing, we have 3 here and we have 3 here. So this would be the highest common factor. Now what I'm going to do now is to factor out this thing, all right? And by that I mean I'm going to put this outside of an open bracket or parentheses, whichever term you want to lend to this. All right, so we factored out 3, so that's the highest common factor. All right, now what we're going to do is to write what's left. All right, so after we factored out 3, the common factor, after we would have taken out the 3, what would we be left with? All right, so here after we factor out 3 out of the 3x, we'll be left with x. We'll put back this sign right here, which is an addition sign. After we factor out 3 out of this right here, we'll be left with 5, all right? And that's pretty much how you would factorize 3x plus 15, all right? So it's quite easy. Another way how you could look at it is that after you obtain the highest common factor, what you did is to divide each term by the highest common factor. So 3 into 3x, you'd be left with x. 3 into 15, you'll be left with 5, all right? So that's another way how you could look at it, all right? So factorization is Very easy, alright, once you get the hang of it. Now, what if we had example 5, PQR plus QRT minus QSW, alright? What if we had something like this? Again, we can find the factors for each term. So we have PQR, and again, this is simply P times Q times R. And we also have QRT, and this is same thing as Q times R times T. And we also have QSW. Alright, and this is same thing as Q times S times W. Alright, so what we can do now is identify what's common in each term. Alright, and we look at each term, we notice that the Q is common in each term. So we can identify that. Alright, so the Q is common in each term. Now what we're going to do now, again, we're going to factor out that Q that's common. So we'll put this outside of the bracket. Inside of the bracket, we'll write what's left in each term after we would have factored out the Q. So after we factored out Q out of PQR, we're left with P and R. And again, we're dealing with multiplication signs here. So P times R is the same thing as PR. All right, and write back the addition sign right here. After we have factored out Q out of this particular term, we're left with RT. So RT. Again, we'll put back that sign right there, which is a minus sign. All right, and after we have factored out Q out of this scenario, we'll be left with SW. All right, and that's pretty much how you would factorize this thing right here, this expression. PQR plus QRT minus QSW, all right? Now let's look at example 6, all right? So what if we had 10Q squared minus 5Q, all right? How do we treat with something like this, all right? So again, we can write out the factors for each term. So we have 10Q squared. This is the same thing as 10 times Q, and Q squared is the same thing as Q times Q. And we can also expand 10 some more. So this can also be written as 2 times 5 times Q times Q, all right? So we can rewrite this thing like this as well. Now, what if we had, let's say we write out the factors for 5Q now. This is what? 5 times Q, all right? Now, we notice that we have 5 and Q common, so we're not going to pay attention to this part of it. What we're going to do now is to identify what's common among this and this right here. When we look at this, we know that what the 5 is common. Look further, we notice that the Q is also common. All right. So what we're going to do is to factor out 5Q. All right. So we can factor out 5Q out of this thing. So factor out 5Q in bracket. We'll have what's left. All right. And what I want to add to this, 5 times Q, we can also multiply this thing by 1. All right. And 1 don't change the value of anything. All right. And I'll explain further on why I did that. All right. So you can better understand the result that we'll obtain. All right. So after we factored out 5Q out of this particular expression, we're left with 2Q. All right, 2Q. And again, we bring back the minus sign right here. And if we factor out 5Q out of this right here, we're only left with the 1. All right, so that's why I wrote it here. So what we did pretty much is to divide each term by the common factor, which is 5Q. All right, so if we divide 10Q squared by 5Q, you will obtain 2Q. If you divide 5Q by itself, of course, you'll obtain 1. All right. So that's how we would factorize 10Q squared minus 5Q. All right. Now, what if we had example 7? What if we had 3R to the power 4 minus 15R? All right. Now, again, we can write out the factors for each term. So 3r to the power of 4 is the same thing as 3 times r to the power of 4 means that we're multiplying r by itself 4 times. Alright, and we can also expand 15r. So let's see what we can get. This is the same thing as 15 times r. Can also expand the 15 some more and can obtain 15 by multiplying 3 times 5. And then we'll multiply the r there. So 15 times r is the same thing as 3 times 5 times r, alright? So I simply wrote the factors for 15 right there, alright? So we're not going to pay attention to this part of it. Again, what we want to do now is to obtain what's common, alright, among these two terms. So we'll look at this, we notice that the 3 is common. I will notice that we can get an r which is common also, alright? So if we factored out 3r out of this thing, what will we be left with? We have r times r times r. If we multiply r by itself 3 times, that's the same thing as r to the power of 3. And again, we have to put our sign back in here, which is a minus sign. And if we factor out 3r out of this thing, we'll be left with 5. Alright. And again, this is pretty much the basics of factorization. So if you're gaining a hang of this thing, then all I simply did, a shortcut way how you could look at it, is that you factored out what's common. So what's the highest common factor for 3 and 15? That's 3, alright? So 3 can go into itself, 3 can go into 15. Then you look at the letters. Of course, r can go into itself and r can go into r to the power of 4. So you can factor out 3r right there. And once you obtain this common factor right here, or the highest common factor, you can then divide each term by the highest common factor to obtain these two results inside of the bracket right here, alright? So that's pretty much what factorization is all about. Now, let's say we had example 8 and we had 15x squared times y minus 10x y cubed, alright? We're going to step up the piece a little bit, so I won't go that detail as the previous examples. If you want to do that, then sure you can, you'll obtain the same result, alright? So what I'm going to do now is to identify the highest common factor in each term, alright? So here we have a term 15x squared y, and we have 10xy cubed, alright? So what we want to do now is to find, let's look at the numbers first. Now, what's the highest number that can go into both 15 and 10 without leaving a remainder? That number will be 5, alright? And again, let's look what's common. We have x over here, we have x over here. So we know that we can get an x out of both these terms. And we see y over here, we have y cubed. So we can get a y out of both these terms. So we can factor out 5xy, alright? So if we divide each term now we're going to divide each term, and how you can look at this, we're going to divide each term by the highest common factor that we just obtained, which is 5xy, alright? And hopefully you would have been exposed to this, so we can expand this some more. So this is the same thing as 15 times x squared is the same thing as x times x times y over 5 times x times y, alright? So we can use x to cancel x. 5 into itself goes 1, 5 into this goes 3 times, y cancel y, so what's left there, alright? So when we do all of that, we'll be left with 3 times x, alright? Everything in the denominator is cancelled. And when we look over here again, we can divide this term by the highest common factor, which is the same 5xy, alright? And again, we can expand these things. So 10, this is the same thing as 10 times x. Y cubed is the same thing as multiplying y by itself 3 times over 5 times x times y. All right. So what we can do now, we can use the 5 to cancel itself, and 5 going to this 2 times. X cancel itself, x cancel that right there. And after y, cancel the y up there, right? So we're left with 2 times y times y. And y times y is y squared. So again, we have to put back our sign here, which is the minus sign. Then write this thing 2 times y, which is y squared. So this is the same thing as 2y squared. All right. So that's what is taking place here. All right. So again, first step, find the highest common factor. Then we divide each term by the highest common factor. All right. So that's how you treat with this particular scenario. All right. But you don't always have to, if you want to do it as detailed as I did the previous examples, you can always try it like that. So it's pretty easy. All right. So let's look at a couple more examples. Now, what if I had example 9? 4a squared b plus 2ab squared minus 8ab. All right. So what I want to do is to look at the numbers first. So the highest common factors for these numbers would have been 2. So we can factor out the 2 right there. And we'll look at the a. All right. So we're going to take the a with the lowest index or the lowest power. And that's just basically a to the power of 1. So a by itself is the same thing as a to the power of 1. And we'll do the same thing for the b because we have b's being common in each terms. All right. So again, we'll factor out b. And again, as I demonstrated in the previous example, you'll divide each term by this common factor that would have factored out of each term, all right? And you can do that as detailed as I did the previous example. However, I won't be doing that, all right? But there is no crime in doing that if you're not comfortable. So I'm just going to look at this thing and deduce what I'll get in the bracket, all right? So if I divide 4a squared b by 2ab, I'll obtain 2 into 4, that's 2. If I divide a squared by a, I'll be left with a, and b will cancel b. So that's that. And then if we look at over here now, so if we divide 2ab squared by 2ab, 2 into 2, that cancel, a into a, that cancel, b into b squared, I'll be left with b minus 2 into 8, that's 4. So we can write the 4 right there. And let's see, a into a, that cancels, b into b, that cancels also. So that's where this thing pretty much ends, all right? So if we factor this thing, we'll obtain 2ab, all right? And in bracket, we'll have 2a plus b minus 4. And a key thing to note, you can always expand the bracket to check and see if your answer is actually correct, or if you factored the thing correctly. So if you expand this bracket, you should obtain the same thing that you originally had, all right? So that's pretty much how you treat with this particular example. What if you had example 10? 18p cube times q squared plus 27p to the second power times q to the third power minus 36p to the fourth power times q to the third power, all right? So this is what we have. So again, we want to look at the numbers first, and we want to identify the highest common factors among each number, all right? Here we have 18, 27, and 36. So the highest common factor for those numbers would be 9, all right? Let's look at the p now. So we'll look at this. We'll notice that p is common in all 3 terms. So we have p cubed here, we have p squared here, we have p to the 4th power. Now what we're going to do is to factor out the p to the lowest index. So p squared, or p to the lowest power, whichever term you're more comfortable with. And we'll do the same thing for the q, because we have q squared here, q to the 3rd power, and q to the 3rd power there as well. So we'll factor out the q with the lowest index or power. So that would be q squared. In bracket, we'll be left with, now we're going to divide each term by this that we would have factored out. So 9 into 18 goes 2 times. P cubed divided by p squared, that will give me, I'll be left with p. Q squared into q squared, those things will cancel out each other. So Can look at the second term now. 9 into 27 goes 3 times. P squared into P squared, those things cancels. Q to the third power divided by Q squared, that will leave me with Q. Put back my minus sign here. 9 into 36, that goes 4 times. P squared into P to the fourth power, that will leave me with P squared. And Q squared into Q to the third power, that will leave me with Q to the third power. Alright, so I can close bracket there. So that's what I'll get if I factor out this thing. Alright, and again, if you're not comfortable with factorization, after you obtain the common factor, which is 9p squared q squared, you can use the long root that I demonstrated previously to divide each term, alright, if that's what you're comfortable with. So that's where we'll end today's video. I hope this video helped. If you have watched this video to the end, please hit that subscribe button. If you haven't yet done it, don't forget to like the video and share it, alright? As always, thanks for watching.